Drew, if you want to present and take it away.
Yeah, thanks. Hey, I really appreciate giving me an opportunity to meet all you folks and speak here. It is my first Splunk user group in a number of years, which is great. I really missed doing Splunk user groups. I've done many here in the Carolinas. So hopefully, if somebody just wants to give me a verbal that you can see my screen.
Yes, we can see your screen. Thanks.
Awesome. All right. So I'll give you a little bit of background about me, and then I'll jump into security detection engineering. If you are working with Splunk on the security side of the house, I think this should be very relevant, at least from a conceptual standpoint, a sort of improved approach to detections and process around that. If you don't work with Splunk on that side, I think maybe some of the concepts might still be interesting from the idea of sort of second level detections and sort of how to run programs to roll out whatever it is you're looking for in your data. So a little background on who I am. As you saw earlier, I'm the Director of Sales Engineering here at Anvil Logic. Anvil Logic is based in the Bay Area, and I am based in Raleigh, or just outside of Raleigh, North Carolina. Prior to Anvil Logic, which I started in June, I was with Splunk for 8.5 years, and hopefully you all can see my T-shirt. I have a drawer full of these. I bleed Splunk pink. In fact, my Splunk experience goes back to Splunk Green days. So as I said, I've done a few of these user groups before. I've been an active part of the Splunk community for a long time, and it is really an honor to work with you folks and speak to you. You can see here, I've been in the software business for a long time. I started in radio station, digital audio broadcast software, got into security technologies around the year 2000 or so, worked for a number of different companies, including McAfee for a number of years prior to coming to Splunk. So I've been in the SIM business for a while, and security analytics and detection is something that is near and dear to my heart, having worked with SOC analysts and engineers and CISOs and folks like that for a very long time. I've been in the business of managing SEs since about 2018, and I'll put a little plug out there for anybody looking. Anvil Logic is definitely hiring on the sales SE engineering side. So if anybody's looking for a gig, please don't be shy to reach out. I'll throw my email up at the end. On the personal side, I mentioned I'm in Raleigh, but my accent might give away that I'm not really from Raleigh. I spent most of my life in New York City. Been married. You can see my family there. I'm surrounded by ladies, which is great, and some hobbies, vices, addictions. You can see down there, and behind me you can see some of my other addictions and vices. But that's who I am. Let me jump into what we're here to talk about today, which is, and I'll give you all a chance to ask questions at the end. But if anything is burning and urgent, please feel free to chime in. I can't really see who's raising their hand, but you can chime in verbally, or I will, if you want to put something in the chat. One of the SEs on my team, Jordan Kamba, out of San Diego, California, is on with me. Maybe he can keep an eye on the chat and answer any questions that pop up there. But what we're here to talk about is security operations and how we can help you, particularly on the engineering side of things. So this is what security operations look like at a 10,000-foot overview, starting with detection engineering. And for those that aren't from the security world, that simply means the process of creating content. So whether you're using Splunk Enterprise Security or core Splunk, this typically involves writing SPL searches that are looking for bad stuff in your data. The data could be coming from your endpoints, your network devices, your cloud systems, EDR, all sorts of things. What is typically driving detection engineering is a program that should be directing what it is you need to detect, right? And those will come from an understanding of your environment, an understanding of who might be targeting you and how they might be targeting you. And I'll have more to say about how those things work together in just a moment here. In between is the work of actually responding to what you find, right? The triage, typically your level 1, level 2 SOC analysts. You might have folks who are doing threat hunting through either raw data or subsets of that data, maybe basing that on machine learning or using just straight up SPL, security essentials, machine learning toolkit, things like that are a lot of things people use for that commonly in Splunk. And then on the response side, there may be some of you here who are using Splunk Phantom or SOAR in its current iteration, or maybe XOR, other tools. This is sort of the day-to-day of dealing with these things. What we're going to be focused on today is what's at the ends, right? The idea of finding and creating content, and then understanding what content it is that we need to create in a bit of a feedback loop. Most folks today are not merely relying on basic detections, but I think it's really important to understand how data science and machine learning can be used to improve detections, tune your insights, look for the unknown unknowns as well. And then that, of course, should be built on a purple team or a red team and blue team. And for those not familiar, it's just sort of the idea of people who are attacking your system, but from the inside to understand where it's weak and vulnerable. People whose job it is to see what those attacks look like and defend against those. And you merge purple and blue, red and blue together, and you get the purple team. So a lot of Splunk organizations that have mature security organizations will have internal purple teams. At Anvil Logic, we have Purple Team as a service that we provide for our customers. But the general concept is you don't want to just throw things out there. You want to actually test and see how things work in the real world as you go through these processes. So this is what detection engineering looks like at a lot of Splunk customers, a lot of other SIM vendors' customers as well. And I'll take you through the sort of, a typical process. Yours may vary, but it looks something like this. Some kind of new vulnerability, a new trend, a new type of ransomware attack, or you heard maybe a few days ago, there's a new vulnerability that got discovered in Microsoft Exchange. So something comes out, or you're just driving your program in a logical way and actually making progress toward covering new things. But in any case, there's an idea. I need to detect this type of thing in my environment. So if it's, say, the Log4j vulnerability from a couple of years ago, what's that going to look like? Well, there's the initial exploit, right? Somebody trying to exploit Log4j vulnerability. So a detection engineer on the security team is usually going to go out and identify the threat one way or another, and they're going to have to do research to understand what that threat looks like and how to identify that threat. It's going to involve a lot of Googling, maybe going to GitHub and looking for code other people have deployed. Maybe you're looking at Splunk blogs. Maybe you're looking at the Anvil Logic security threat report newsletter, which I'll plug again at the end. If you're not looking at that, you should be, but you've got this research going out that says, I need to be looking for this thing, and here's how I'm going to look for it. After that, we've got to say, all right, we want to create a detection. Usually it's pretty simple to go ahead and create a ticket, but it's going to involve moving in some sort of a ticketing system, maybe a Jira, something along those lines. And then some of the heavy lifting comes in here. All right, I've got an idea of what it is I need to look for. I know what maybe the string is that I need to look for, or the pattern in the data. Now I need to build it and test it. What's interesting is up at the top here, you've got somebody who is a security domain expert. And down here, you have somebody that needs to know the language to create the detection. And this could be somebody that's an expert in SPL, or maybe the data is in another platform where you have some other language you need to know, SQL, KQL, maybe Python, something like that. These may be the same person. They may not be the same person. And if they're the same person, it's a pretty skilled person, somebody who's probably hard to hire and fairly expensive for a lot of organizations. So, in other words, there's not enough people who can do this kind of work in most organizations available to actually do it, but people are doing it. Once you've tested it, you see what it looks like, you're doing some of this real world modeling, you need to document a run book. And for those not familiar, it's what does the SOC analyst do when one of these detections throws an alert, right? So maybe they're living in the incident review dashboard in enterprise security, or maybe they're getting tickets in ServiceNow, or they're using Phantom or something like that. What do they do at that point, right? And this could actually be something implemented in code like a Phantom runbook. Or it could, in fact, be simple instructions to contact the owner of the system, reformat the hard drive, what have you. But it needs to be documented at this engineering stage. And then once it's all been tested, documented, it needs to be deployed, which typically means in the world of enterprise security, saved as a notable event search, or in core Splunk, just simply a scheduled search. And other platforms have their own flavors of this. Now, that's all what's involved in the initial setup of it. And you can see here, I've got sort of rough timelines associated with it. But then there's also the process of ongoing maintenance and tuning. And for that, you need good communication between the people who are actually receiving those alerts downstream and the people who are creating those alerts. And by the way, for you non-security folks here, take this process and turn it into whatever, right? Creating alerts when your web app infrastructure goes wacky, or a server goes down, or some part of your cloud infrastructure starts passing certain thresholds, or whatever it is. This process is going to look familiar. We're going to address it specifically in the world of security today, but obviously a pain point across a lot of domains of monitoring, right? And then, of course, there's the ongoing maintenance of it, and then monitoring. So how do we have the people who are dealing with alerts feedback information to the people who are creating alerts to tune that? And do we have any machine learning models in place to look for what's causing the noise, or maybe even ways to improve those alerts, or find things that are unknown in there, right? Do you have version control as that goes through? So this is a very painful and time-consuming process for a lot of security organizations. It usually takes a number of days to go through one of these detections, this whole life cycle. And that's, if it's an urgent one, sometimes they can even, I've had customers tell me it takes weeks to go through this process. And of course, it's reasonably disjointed. It touches a number of different systems, processes, and people. So this is sort of the first pain that a lot of folks have with detection engineering in modern SIEM and security environments: the slowness, the difficulty. Also, a lot of those alerts that you're generating are showing these detections in isolation. And that generally creates a lot of noise outside of the context of what else is going on. I'll have more to say about that through the rest of this presentation. Another problem people have is they don't have all their data in Splunk, right? It'd be great if you could do that, but it costs money to pull data into Splunk. It costs money to get data out of public cloud infrastructure, for example, Azure egress cost, or AWS, or what have you. So sometimes you'd like to search data and combine it with the data in Splunk, but it's not in there. So that is a problem we do help our customers solve. There are ways to solve it with APIs and things like that. And I know Splunk is working on things like federated search, but unfortunately, it's not really where it needs to be today to search data in external repos. So this is a bit of a pain point. And then lastly, how do I know what to look for in the first place, right? I mean, obviously, when log4shell type vulnerability comes out, the good news about that day is, if you're a security engineer, you know what you're working on that day, right? You're dropping everything else to deal with it. But most of the time, you need to understand, okay, what data sources am I missing that would help me cover what I need to cover from a technique perspective? And when I say technique, I mean the techniques adversaries, hackers, attackers, however you want to look at them, are using to break into my organization's infrastructure, to steal data, to do damage, to deploy ransomware and things like that. So I'll talk a bit more about that in the next slide, but you need to understand that at a point in time, and ideally you need to understand in real time what's the next thing I need to do to get the most bang for my buck to protect my organization, identify those gaps and measure risk. So to drill down on that last point a bit, how do we measure the effectiveness of detection engineering? And a lot of this, I'm going to look in the strategic maturity side of this slide. I'm not going to worry about the operational side for the topic we're talking about today, but it's understanding two key things. One is, what is the data that should be in scope, right? And where is that data? And two, what detections do I need to have in place? What rules, what Splunk searches do I need to have that are going to find the bad stuff? And where are there gaps in ways people can attack me where I don't have the data or the detections in place? And here I'm going to pop out and show you a little quick mini demo on what we're talking about. So for those of you who don't work in security, or those that do, and maybe you're just not familiar, there's an organization called MIBR. They're a nonprofit organization. They advise the government on a lot of things, and a lot of private sector companies look to MIBR as well for guidance on security programs and things like that. So MIBR came out with this model of what an attack looks like by advanced persistent threats or sophisticated attackers that are trying to attack your organization. And it has this model that has these tactics across the top, and I can scroll over here. And within each of these tactics, like reconnaissance or initial access and execution, there are a number of these different techniques and sub-techniques that attackers use. Most security organizations, most leadership are driving their programs based on this, right? The MIBR attack is a widely used framework for saying, do we have the coverage we need? So the first little bit of useful information possibly I'm going to be providing here is, how do we do this, right? So the first thing I'm going to advise, if you're not doing it already, and of course, people that are building this program probably are familiar with these problems and the difficulties around it, but it's to use that MIBR framework to understand what is in scope that I need to monitor for. And that's going to start with understanding, and you can see here I'm in our Anvil Logic platform. Happy to talk to folks about this offline or separately. I'm not here to pitch Anvil Logic. I'm just going to present these concepts here. You can do this in an Excel spreadsheet or other places. It's just obviously a lot more manual. But number one is understanding which platforms are going to be in scope for you to monitor. If you're in Azure but not in AWS and not in Google, then you don't need to worry about Google or AWS. You need to only worry about Azure environments, right? If you're only a Windows shop or a Linux shop, right, then we can focus on one or the other, or if Macs are not in scope or what have you. So start with platforms. You can understand the threat groups that are out there that are targeting organizations like yours, your industry, your geo. If you're not an Eastern European government, there are certain threat groups that you don't need to worry about, right? Or you're not South Korea, you probably don't need to worry about other threat groups. From there, you can scope down. So taking that whole matrix of these tactics and techniques, understand which ones are high priority, right? You'll see we've color-coded it here into red, orange, and yellow to have high, medium, and low priority, and understand which techniques and tactics might not even be relevant in your environment. And why is this important? Because it's going to help you target and prioritize the list of data that you need to get into the system and prioritize the types of detections you need to develop and deploy. So from there, understanding the techniques that are in scope, how they're prioritized, you can derive which data categories are going to be important for you to bring in. So in most security environments, things like endpoint logs, EDR, antivirus are almost always going to be a high priority log source. Whereas not everybody needs to worry about, for example, Azure activity logs, especially customers that don't use Microsoft Azure. So, organizing this around that MIBR model is the first step in understanding things. And then going beyond that, understanding which detections you have in place. So literally taking your list of enterprise security correlation searches, other Splunk searches, if you're using Azure Sentinel, if you're using some other SIM or whatever you have, taking that list and then mapping it so you understand where you have coverage and where your gaps are is going to be a key step in understanding what you need to do to target your detection engineering efforts, as well as to target which data feeds you have coverage for and which data feeds you don't have coverage for. So example, I can say, based on my priorities, I can see I don't have AWS CloudTrail logs in here, and those are really important. So at that point, make a decision to bring those into Splunk or figure out how else you could search those logs in a meaningful way for detections. So that's all around setting the priorities, understanding your maturity level, understanding your gaps and risks. And I think that really is a prerequisite for effectively guiding and measuring on an ongoing basis the effectiveness of detection engineering. So I'm going to take a breath there and pause and see if there are any questions at this point. All right. I've caught my breath, so we'll keep moving there. All right, so let's talk about the detections themselves. This concept, the pyramid of pain, is something that's been out there for a while. I can't remember who exactly invented this idea, but it's around attackers and how much pain they have in trying to evade your detection mechanisms and your prevention mechanisms in place, right? Your security controls and monitoring. So a lot of organizations are kind of focused on blocking or detecting attacks based on these things at the bottom, right? Looking for a hash of an executable, an IP address, a domain name. The problem with doing detections at this level, I mean, one thing is it's fairly easy to do detections, right? Take a list of naughty IP addresses you can pull off the internet and block those IP addresses, or generate alerts in enterprise security when you see those IP addresses. Not really very effective, however, because for attackers to change these things is trivial, right? It is no pain at all to change a hash value, an IP address, a domain name. It's an arms race, and the bad guys are winning when it comes to this stuff. However, as you move up the pyramid, looking at things like host artifacts, tools that they're using, and most importantly, the techniques, right? The TTPs, tools, techniques, and procedures that these guys are following. If you're looking for behaviors instead of artifacts like that, it becomes much more difficult for an attacker to evade your monitoring and your prevention tools. So when we're going to create detections, good, effective detections, we're going to focus on behaviors. So that's where I'm going to go here and kind of talk about how we can build better second-order detections based on behaviors. So here's what detections look like today to some extent, right? You've got your events, and if you use Splunk, you know you've got all kinds of events in Splunk. You've got events from your applications, you've got events from your security tools, your network tools, your endpoints, your cloud infrastructure. It's all sitting there just thrown up, you know, and of course, as an 8-year Splunk veteran, right, get all your data into Splunk, search all of it for security because all data is security relevant. And there's no better search platform on the market than Splunk in terms of being able to search that data with the power of SPL and finding interesting events, right? So traditional alerts, most of the alerts, the searches you're going to have out of the box today for enterprise security are going to focus in this area, and they're going to find things that are interesting, things that are anomalies. One of the ones I always used to demo when I demo enterprise security was brute force logins, right? So if I see a given user account that has, you know, 5 or 6 bad logins, failed login attempts, followed by one good login attempt in a period of, you know, a minute, 10 minutes, whatever you want that window to be, boom, generate a notable event in enterprise security, go to your incident review dashboard, and then figure out if it's a legit thing or not. The problem with that is those types of alerts, those things that just simply look for strings or basic patterns in raw events, tend to generate a lot of noise. So what I'm advocating for here today, and you know, Anvil Logic certainly makes it easy, but I just want to kind of talk about the concepts today, is to look for next level, next order events. So maybe some of you are familiar with the idea of risk-based alerting. Splunk's been talking about that a lot in enterprise security, and they've started building out some basic frameworks to make that possible. Still a little difficult to do effectively in there, but it's a lot better than it was when you had to sort of roll your own risk framework extensions and things like that. These can be a very interesting and effective way of turning down noise, but even more effective are what we call threat scenarios. So some combination of these sort of second level detections are really important in terms of turning down the noise, turning down the alert fatigue being delivered to the analysts in the SOC. Now, events of interest are things like, you know, a new executable we never saw got ran over here, or there's a string that indicates maybe somebody's trying to exploit log4j vulnerability, or, you know, literally thousands of different things that could fall under suspicious, but not necessarily actionable in isolation without additional context. So we don't want to generate alerts until we see those connected dots, right? So here's a simple example of a threat. You know, we have multiple threat identifiers or events of interest over here. We're going to say, hey, we're looking for a particular Windows event code 4688 or something like that. And we're looking for this weird process name that a user shouldn't run, right? Maybe we're going to exclude it if it's run by a, you know, a system user or something like that. But if we see those things together, then it starts to put together an interesting pattern, right? We connect the dots on maybe a host or a username within a certain time frame. And from there, we've generated a threat scenario, A plus B plus C, centered around a common object, a user, an endpoint, you know, a URL, a doc, or whatever, something. That starts to become something that is worthy of generating an alert and kicking off a playbook, an investigation, something that needs to be triaged by the end user. I'm going to give you examples of this in our platform with my remaining time, but I just want to get that concept out there of these second order alerts, looking for atomic detections, little individual things that are suspicious, and then combining them together. And this is where you're going to get really high fidelity alerts. You know, how can you do this in Splunk today without Anvil Logic, right? There are things like summary indexing and stuff like that, where you can sort of collect these things and string them together. It takes a little bit of SPL skill to be able to do something like that, but it's, you know, people have found ways of doing this, like with risk-based alerting. And then you have this available to you, right? So this is sort of what implementing this would look like in your environment. It's what it looks like when you implement it with Anvil Logic, is that you're using, you're querying your data. Presumably most of it's going to be in Splunk for most of the folks on this call, but you could also maybe search other systems and pull in data or alerts out of those, get some alerts directly from your EDR tools, your email scanning tools, pull those in. And here's a key thing. You're going to want to tag that data, you're going to want to normalize it, and you're going to want to enrich it. So what I mean by that is, in order for you to understand that we have a real attack that's following an actual real-world model, moving through different phases, for example, of the MIBR framework, different tactics, or maybe you're more used to the Lockheed kill chain paradigm, whatever, you're going to want to bring that data in and tag it as such. Which phase, which techniques, which tactics does this map to? You're also going to want to enrich it with data that might contextualize it for you, asset and identity data, data from your threat intelligence platforms. Pull all that together and, of course, normalize it. So today, for most Splunk enterprise security customers, that would mean using the common information model. You could also do inline normalization, as we do at Anvil Logic, using inline macros to take the raw data and extract the important fields out after you've filtered for the interesting events over here in the initial search. And I'll show you some examples of what that looks like in our platform. Once you've got those interesting events, events of interest, EOIs, you're going to store them. And here's where I'm talking about using some sort of an index to collect these first order atomic detections. Most of them are not going to generate actionable alerts. Some of them might, right? If the thing is very, very high fidelity, if you have very high confidence that that simple detection in isolation should be investigated, then go ahead and raise an alert. Go send it to your SOAR tool, your ticketing tool, enterprise security, no problem. But most of them are just going to be interesting and will be more interesting when we can connect the dots in context. From there, you do the dot connecting, right? So here's where you start building searches that look for risk profiles or threat scenarios, like we just described. Look for, you could even use machine learning, for example, to start doing notebook-based searches or other types of searches against this data to look for unknown unknowns. And you can also, use other types of searches against that. And then when we find something worthy of an alert, we kick it off into our case management ticketing SOAR tool from there. So everybody following? Anybody lost? Anybody have any questions? All right. All right, I'm going to jump into a demo and kind of illustrate what one of these things looks like over here. So popping in over here, this is what I mean by a scenario-based detection in Anvil Logic. So, and again, you can build these without Anvil Logic. It's just a heck of a lot easier in Anvil Logic. So again, I'll show you real quickly what it is I'm going to illustrate. With the Log4j vulnerability that came out relatively recently, the way an attack appeared would be somebody would run an attack against, a web application or something that looked like this, right? JNDI LDAP with, some string with some exploit code in there. From there, they were able to run an executable, right? So this is initial access. This would map to the MITRE executable phase or execution phase. And then there's some communication between the compromised system and the attacker, what they call C2 or command and control. This is what the attack looks like. So we're going to want to write individual detections for all three of these, but we're not actually going to want to alert on those. What we're going to want to do is build an alert based on a combination of those individual attacks or detections. And then I'll pop right over here into our interface. And this is actually what represents that. So we've got a little description over here. We've got some mapping against threat groups and kill chain phases, but we're looking for stage one, which is the exploit of the vulnerability itself. And you'll notice here I have a graphical representation. Anvil Logic customers are able to build this without actually writing any code underneath it, or they can use the ones out of the box, but I'll show you what the code looks like. So we're saying is phase one, if we see this identifier, and I'll drill down and give you a little overview here. This is saying I am looking for, and let me zoom in on this because, you're a bunch of Splunk people, you might appreciate what's going on under the covers here. This should look familiar to most of you Splunk folks here. This is SPL, and we're saying go look at WAF data. So these macros simply pull back WAF data from your Splunk index. You just map it to the index that it's there, and we're looking for this JNDI search. You'll notice we're using term statements here to make the search very performant. If you're not familiar with Splunk term, go look it up. It's a very useful function that can make searches very, very fast. We're using a regex command here to also map on this. And then we have a map macro, which actually does the normalization similar to the normalization you do as part of accelerating a data model for a common information model. We're just pulling the things out over here, creating a new field called string with a rex command. Then we're applying a bunch of metadata to it. We're tabling it. We're enriching it. And this is also a key part. If you're going to run searches that do this sort of thing, these second level searches, create something like this, right? We're creating a new field that takes information that we've got out of those detections and builds an explanation for your analyst to work off of and just writes it out to a new field, right? You can do that through an eval command or something. And then here's the part where I mentioned, you have to now collect this in an index so you can do those second order searches on it. We're actually writing this out to Splunk in an index using the HTTP event collector or HEC. You can do this through the collect command or things like that. There's a lot of ways to actually implement this. Make sure when you do that, you collect all sorts of useful metadata around it. This is the enrichment component to telling you, labels, asset and identity information, data categorizations, additional custom tabs, and of course, mapping it to MIBR techniques and sub-techniques that are relevant here. So remember, just phase one. What we're going to do when this fires off is only write to that index. We're not generating an alert. And I think that's important because if we generate alerts here, it's going to generate a lot of noise. But what we're doing with this then is saying, hey, if one of these fires, we're going to run this second order search that looks for one firing with a common correlated host. And this can be any sort of entity, right? As long as you're normalizing your data fields, you can check across these. Within 5 minutes, if we see one of these things fire on the same host, and I'll drill down on one just to show you what we're looking for over here. This would be a suspicious process spawned by Java. And I'll spare you all the details here, but we're looking at Windows events and looking for certain suspicious executables being called by a Java process. And then again, doing the same sort of filtering, tagging, normalizing, and enriching. And I'll spare you all the further details in the interest of time, but we're looking for that initial exploit followed by indicators that might show the Java or Unix, Windows or Linux versions of suspicious executables, because that is what your attacker is going to do next after they're successfully able to exploit this. So maybe this comes from your WAF, this comes from your endpoint logs, and then we're going to look for command and control events, right? And you can define this very broadly. You can say, hey, if I'm collecting metadata that says, that this particular suspicious activity is associated with command and control, then I can just search that metadata. I don't actually have to know what fired off. And the beauty of it is, as I roll out more detections to look for different types of command and control exploits and detections, they should automatically be caught by a second order search that looks for something like this. Now, these searches can be fairly complicated. You can see here a whole bunch of data, SPL, that's, looking here and collecting, looking through our index, our normalized index that we're writing out to the HEC and doing, taking this logic that I drew out over here and turning it into SPL to actually do that second order detection. But what's going to happen is we're going to get a very high fidelity detection delivered to the SOC at the end of this. That's going to be actionable and usable by your analysts. So I showed you a lot of stuff there. Any questions on any of that? Oops. And I'll give you another example of one here. Would be a common ransomware attack pattern. You're all probably familiar with ransomware. This is a typical way we've seen APT groups pushing this out. Would be number one, send somebody a Windows document or an Office document that's got a macro in it. The user opens the Word document. It then runs a PowerShell command It's encoded, so it's hard for your EDR to block it. Maybe it downloads an executable like Cobalt Strike. It's going to make some command and control web connection, so it's going to upload the private key, delete it off the local system, start encrypting things, and then it's going to use AD-find, which is a command to go move laterally in the organization. So I could start to show you real quickly here what it looks like to build this out. We're going to do it graphically here in Anvil Logic, but it's the same general concept whether you're writing this out in SPL or building it with Anvil Logic. I'm going to look across a given host. This is my common entity where I'm going to try to find these things. And what I'm going to say is anything in the MIBR attack that might map to initial access. And I'm going to look again. What I'm searching for here are my first level detections. I'm going to say I'm looking for something here that has, I know that mine have the word document in them. So I can see how I have malicious document execution. This is just simply first order detections that are looking for malicious macros. I'm going to say, all right, if that happens, and then within, 30 seconds of me firing that, and again, you can code all of this in SPL, I see something that maps to an execution activity, right? I'm going to be specifically concerned about this, maybe on the endpoint or on Windows systems, something like that. So we'll just say we're going to look on endpoint systems over here for this type of activity, etc. And then I can continue to build this out and look for the abnormal web connection, the AD-find execution, build out my SPL here and run this one. Now, when this one fires, I'm going to run this in alert mode. I'm going to have this kick off a SOAR process, or I'm going to have this open a ticket, or I'm going to have this push something out to my incident review dashboard, whatever process I have in place for this. So I'm just going to wrap up here with a few more slides and then give you guys a chance to ask any questions and continue the discussion here. Just looking at the time. I won't go through all the details of this slide, but I do want to draw your attention to we're working with a very large $50 billion financial company. And by implementing these type of second level threat scenario based detections, using our platform, they went from 8 terabytes of raw events to a few million warning signals down to 350 alerts in a 60-day trial of our product, which is 6 alerts a day, right? Which is a very manageable amount. And these are going to be very high fidelity alerts, right? So they're probably going to involve some escalation. They're probably going to involve some activity on the part of the SOC analyst. So this is a really good number to get your alerts down to a day in terms of actionable load that your SOC analyst can handle and do a good job. And it's going to cut out a lot of the noise, a lot of the time waste, and really extend what your team's able to do. So I definitely recommend, let me just kind of hit a summary of what we're doing. Number one, effective detection is going to require getting good data in the system, knowing which data is the right data, having good processes in place to manage that whole life cycle, and then being able to measure and drive what the next thing you need to ingest or detect is. Not every detection, those first order detections do not require a response from an analyst, right? Those things should just be written out to an index somewhere and searched later. And then you need to base them on real world attack scenarios and risk thresholds, not on everything that matches a string or an indicator of compromise. Got a couple of URLs out there. I'll put them up on the next slide as well and kind of keep that on the screen here. But if you want to learn more about the Pyramid of Pain, we've got an Anvil Logic white paper on that, or just go search Pyramid of Pain. And we have this great newsletter called our threat report that comes out about once a week, and we'll keep you up to date on all the latest security trends, threats, vulnerabilities that are coming out there. It's completely free. You can even see we've got logic that can help you detect those. And lastly, I'll throw my email address up here as well, D'Auria@anvilogic.com. If anybody has any questions after the fact, I'd love to talk to you and kind of go through some of this stuff with you. So I'll keep that up there. And I guess you know what I'll do, make everybody's life a little easier. I will just put this in the chat, and I'll stop sharing my screen and turn things back over to Becky. Hopefully that was helpful.
Thanks, Andrew. It's very useful.
If I can figure out how to stop sharing my screen here, we'll be in good shape. Let's see. There we go. Found it. All right.
There you go. That's very cool.
All right.
So you have lots of people doing the Log4j vulnerability, I assume.
Oh yeah, yeah. Everybody had to drop everything that day to deal with that for sure.
But more than that, right? It seemed like it was ongoing. It seemed like, but wait, there's more. I mean,
yeah. Absolutely. And that's it's an interesting point, right? Because your detections that are effective today may not be effective tomorrow. Maybe they find some new way of obfuscating it, or another vulnerability that extends that one is detected. You can then add another first level detection, write that out to your index, and depending how you've written your second level detections, your scenario based detections, continue to find that, right, with just minor modifications. But also having some version control system in place. Anvil Logic provides a platform for that, but I've seen other customers use things like Git to manage their version control on Splunk searches. It's a little more manual, of course, but if you have a big mature organization, it's very helpful to use something like that.
That's cool. How do you keep your customers updated? Shit hits the fan, and then how do you make sure that people know right away what to do?
Yeah, absolutely. So we have a number of ways in the platform of pushing we call trending events. So, for example, the recent Exchange vulnerability, we pushed out something. So anybody on our platform logged in and they saw, hey, here's something new. It's Microsoft Exchange. Here's the detections you can use. Just hit the deploy button and push those out. We also send out a weekly newsletter. But in the case of the Exchange vulnerability, we sent out a supplemental newsletter telling everybody about it right away with links to the detections that we were providing. So I'll just say, if anybody's not an Anvil Logic customer and they get that newsletter and they're interested in seeing a sample of the types of detections, click the link, let us know what type of data you have, and me or somebody on my team will send you a sample to give you an idea of how that would work. So yeah, certainly in a fire drill situation like that, it's real important that we get that news out. We also have a Slack community channel that you could join. Our customers is called Anvil Logic User Groups. I'm trying to see. It's anvillogic-usergroups.slack.com, and you could be informed very quickly right there as well. I'll put that in the channel here.
That's cool.
Great question. Yeah.
Do anyone else in the user group have questions for Andrew?
Actually, I do.
Yes.
You said that LBR is a little bit tough to work with. What is the thing you missed there and Anvil Logic brings to the table? I got a lot of problems with LBR, but I would be quite interested in what is your issues with it.
It just seemed fairly limited in terms of what to look for. I worked with RBA when we were first building the concept out, and it had to do with extensions to the risk framework, which was kind of made prior to RBA, right? The risk framework was just sort of a way to accumulate points against a given entity when it came out. And what they sort of built was a little tacked on in terms of extending a few extra fields. It doesn't really, it's good. I don't want to say it's bad, right? It just seems to be a lot of customers have a hard time actually getting it working successfully. What we do is, our focus is primarily on delivering the actual content. So you don't necessarily have to worry about kind of setting the thresholds and tweaking them and playing around with those. And we deliver content that is even more focused on scenario-based detections, which tend to be a bit higher fidelity than simply the risk-based detections. So I'm not sure if that addresses that. I'd be happy to kind of go into depth if you want to see, offline. Just hit me up, and I'll be happy to give you a kind of a full-blown demo of how we do things.
Okay. Because the aggregation itself of multiple notable events to a really actionable alert is quite a similar concept.
Yep.
Yes. It's
a similar concept. And we have the same sort of idea, right? If you have 3 CrowdStrike alerts that come in within 60 minutes on the same host and they cross, MIBR domains, it is effective. It was more the mechanism of the implementation in enterprise security. So we agree with it conceptually. And I'll tell you this, even in enterprise security, there is the concept of sequenced events. But that, it's been a while since I touched it. I remember it being fairly clunky.
Haven't seen somebody using it.
Yeah, I haven't seen anybody using it. And the way we do sequence events or threat scenarios, we can actually cover whole MITRE tactics. So it's kind of criteria based, right? So it aligns much more with behavioral based rather than saying if these 5 particular correlated events or notable events occur, followed by one of these, right? We're saying if anything that maps to this MITRE category or matches the naming convention that shows that it's associated with CrowdStrike or whatever, right? And that enables those scenario-based detections to automatically grow and expand as my library of deployed detections increases over time.
Yes.
So our approach is a little different, but yeah. All right, that's a good question, Daniel. Any other questions?
What's new coming?
In terms of what we're doing, well, we're expanding some data platforms that we support, right? Obviously, we're a big, about half our company comes from Splunk, and we're a big believer in Splunk being an awesome logging platform. But we support a number of different logging platforms today that we can search out of the box without having to bring data into Splunk if it makes sense to do that. And we're always investigating new data sources we can bring into new platforms based on what customers are asking us. If you want to bring it all into Splunk, that's also fine with us too, of course. We've got some, so we have a framework for our detections. You kind of saw a glimpse of that when I had my, that big SPL search up there that said, first we pull the data in, then we look for the logic and this and that. We're developing a platform that will truly unify search, allow you to build those types of searches in our framework graphically without having to know any SPL or SQL or KQL behind it, and then just specify what platform you want to run it on, and boom, deploy it in the appropriate platform. It'll write everything behind it for you. So that's kind of a big thing we're developing. Probably need to put you under NDA to tell you more about that, but it's a very interesting development there. We're doing a lot of stuff around data health, right? So a lot of Splunk customers have trouble knowing, is my data good quality? Is it coming in a timely manner? Am I getting the right Windows events? Am I getting the right Linux events? We're getting events from enough machines. We are automating the process of understanding the health of that data in an ongoing real-time basis for our customers. So that's a big pain point. I know a lot of people struggle with common information model. We're going to fix that. So that and a million other things, but those are kind of the highlights.
That's another question I would probably have. As far as I understood, you got your own kind of data model.
That's right.
What was the pain point? Because we got a data model from Elastic, from Splunk, from Curator, now you got another one.
So the data, we don't actually have a data model per se. We're looking for field names that align with the common information model fields, but we don't expect those to be in an accelerated data model. We actually extract the same field names in line with macros in the search. And it is very performant because of the way we run the filtering up front. Where we have a data model is for those first order detections, those events of interest. And again, the field names are going to look very similar to the field names in the common information model. But we have other fields like what MITRE tactics does it map to? What adversary groups does it map to? All of those other metadata fields, we've added that in our events of interest data model. So you can almost think of it as an extension of the common information model that makes those second order scenario-based detections possible.
Because the greatest pain point I currently have with Splunk, and I think that a lot of people do suffer the same issue, is the part of the normalization. So I was quite surprised that you not choose to get those contents within your solution and extract those interesting fields on your own.
Yep, that's right.
It's a lot of work.
But you know what? The nice thing about it is it's easy to adapt it for different organizations, right? It's fairly simple to fix something that's broken. And not have to rely on, I've seen a lot of pain points between security teams and Splunk teams when the platform is owned by a team other than security team, because the data is not being properly ingested, and then it's not hitting the common information model, or something changes and it breaks. This gives the security team the power to go in and make those adjustments on the fly as needed, and it tends to work really well for our customers.
Okay.
And there's tons of macros in there. I could spend all day showing you macros.
Well, that's great. I think I'd like to wind up the meeting and thank our speaker. Thank you
My
very
pleasure.
much, Daniel. And maybe I can get the slides from you,
Sure.
if that's okay. And then I'll put them out on our community channel along with the recording. And then we'll see everybody next month in person. I'm just so excited. So if you're in the Bay Area, look for an announcement. But November 2nd in 6 o'clock in the evening, swag, hope to have food, and great speakers. So come everybody.
One
Yeah.
point I would really appreciate when you could do a hybrid model, because I'm based in Germany and I'm jumping around from, I'm joining all user groups.
Yeah.
That sounds quite interesting to me. So, but
Yeah.
I can totally understand that on premise. So to see
Yeah.
the folks, it's quite enjoyable, but I enjoy it as well.
I know I've been to ones in India and all over Europe and all that. I love that. I don't know, maybe the first one in person, it's just me setting it up. It's not my area of expertise, right? I'm production engineer for Yahoo. But I don't know if I'm going to be able to get the virtual thing for that meeting. But we are going to have other virtual meetings after too. So I'll do what I can, but I don't know if it's,
Sure.
you know, we'll see. I'll see how hard that is. Okay, thank you, everybody. And thanks, Andrew.
Thanks, everyone. Appreciate your attention. Have a great day.
Thank you.
Yes.